All right. Welcome everybody to today's Getting Started with Kubernetes and Rancher 2.0 online training. Really excited to present this material to everyone, and it looks like we have a good number of people joining the line. I'm sure more will come. So I just want to start out by giving some overview of what we plan for you all today. Our main objective is to give a solid technical introduction to what Kubernetes is, what Rancher is, what do those mean, get the concepts, that the fundamental concepts in that will help you be able to understand and get a good beginning. Look at Kubernetes workloads and clusters and things like that. What is the difference between a container and a pod and things like that as well. We do have a lot of slides, but this will mainly be demo material. So we will be demoing some more, which means it's very hands-on and responsive to what you all are interested in and what your questions are. So if you do have questions and you have them now, go ahead and start putting them in to the questions chat, and we can start answering them and incorporating them into the material, and also take pauses during the presentation to answer your questions as well. We do our best not to leave with questions left over. We have 90 minutes scheduled for this, so we should be able to get to everything. And if we don't, please follow up with us. And on that note, as a way of introduction, my name is Matthew Shear. I'm kind of the community advocate at Rancher, and you can reach me on Twitter or on the Rancher Slack channel. Links to those are further on in our presentation. And our main presenter, the main knowledge base, is our software engineer, Kanara Shah. Thank you, Kanara, for being on here and taking the time out of your week to do this for everyone on the line. And again, Kanara's GitHub handle is in the slides, and so please reach out to us following this presentation. We're happy to help. Just as a little bit more context, we do come into this training with an assumption that you are familiar with containers at least a little bit, kind of a basic understanding of Docker containers. If you don't, it's okay. We'll still do our best to answer your questions. If they're really outside of the purview of the training, then we might refer you to some other resources. There's a lot out there. And we try to stick more to Kubernetes and Rancher here. But if you do have more questions, we'll do our best to follow up and help. If you want to have your own instance of Rancher going while we're doing this training, you can get it started in just a couple minutes, get it up and running in just a couple minutes. Go to the deploy button in the top right corner of the website, and that'll take you to the quick start guide, which should have all you need to get a one node instance up and running. Follow along with the demo. Further resources as well, more help is out there. It's a huge community. Rancher is open source. Kubernetes is open source. There's a lot of contributions and conversation going on about these two technologies. Slack.rancher.io is where a lot of our community is very active day in and day out. Our engineers are on there as well, answering questions, trying to help people with this work. The forums also are really great, forums.rancher.com. And you can reach us there or reach us on GitHub. And so with all of that out of the way, we're going to get into the meat of the material now, and I'm going to switch this presentation over to Kanara. Are you ready, Kanara, to slides? Okay, cool. Let me switch this to you.
Do you see my slides now?
I see your slides. You're good to go.
Okay. So hi everyone. Just as Matthew said, today we'll be first doing a couple of slides, just a bit of background information, and then we'll jump on to the demo. My name is Kanara. I'm a software engineer here at Rancher Labs, and I've been working on extending Kubernetes since a few months now. Let's just start here with why Kubernetes. Kubernetes has been growing a lot and very quickly, which is, I think, one of the reasons why you're here. So before Kubernetes, we had a product called Rancher 1.0, where we worked with different orchestration engines like Docker Swarm. We had our own orchestration engine and so on. But with 2.0, we realized that Kubernetes was just getting bigger and bigger. It was supporting good and robust design patterns, and it was just basically taking over. There are a lot of software companies who are using Kubernetes. If they're not using it, they are trying to experiment and they're trying to find out if they can switch to Kubernetes. So, like, this is just a list of software companies who contribute to Kubernetes, and you can see that it's not just Google. There are a lot of other companies who are interested in making it better and making it grow. So one of the downsides with such a huge and complex system like Kubernetes is there are just so many ways to do things. Like how do you deploy your resources? How do you do auth? How do you do that efficiently? How do you manage your resources? So one of our goals at Rancher when we switched to Kubernetes with 2.0 was to make all of this stuff easier and using Kubernetes objects, using Kubernetes resources to make some of this stuff easy. One of the other problems is that because Kubernetes moves and changes so fast, it becomes kind of hard to keep up with it. The one thing about Kubernetes is how often they do releases. And so even if they are doing minor releases every few months and they do technically follow Simbar, they can break in between major releases. So just because you go from 1.8 to 1.9, it doesn't mean that they didn't add or delete or make changes in API. So keeping up with that can be a bit painful, and it's a good idea to have some help, which is what Rancher can do for you. Another downside to Kubernetes is its pretty steep learning curve. So there are so many objects and so many resources that it's not always easy to dive in and just, expect to know everything. It's hard to understand how to set up a cluster and which object to use and when. Also, Docker knowledge doesn't directly translate to Kubernetes. So just because you can run Kubernetes, it doesn't mean that it's going to be easy. So how about Rancher and Kubernetes together? Like, how can you use the features and power of Kubernetes in an easier way? So we provide an easy to use UI. It's a very nice UI. You can just use it to set up auth, configure and deploy workloads and a bunch of other things that we'll talk later on. We provide infra management across multiple clouds and clusters. So it's like a single point to manage all your clusters together, which a lot of other systems don't do. We provide automated deployments. So as I mentioned earlier, we do keep up with the latest Kubernetes releases. We are going to give you management of workload, RBAC, policy, and project management. So project is a Rancher construct, and we'll be talking about that later on in the demo. We also offer 24/7 enterprise grade support. So everything that you see today in the product is open source. There's no difference between enterprise and our open source software. But if you do want support, we offer that. So Rancher can pretty much run on top of anything that you can think of, be it bare metal, any of the IaaS services, or any cloud provider. So this is just a general overview of our management platform. At the top, you have your application management, where you can talk to UI, the CLI pieces, monitoring, logging, basically how you talk to your rancher. Below that, we have our Kubernetes management plane, that basically talks to and provisions clusters and sets up things for you. And then we have different places where you can straight away deploy Kubernetes like GKE, AKS, EKS. And down there, we have our bare metal or any of the IaaS hosts. So just as I said, Rancher can pretty much run with anything that you can bring up. Basically, anywhere you can start Kubernetes, you can bring that in into Rancher and we'll manage stuff with that. So here is a quick overview of how Rancher works. In the middle, the square box is the Rancher server, and this is what basically you're going to spin up and run. The etcd that Rancher uses is the same etcd that is running Kubernetes. So if you back up etcd, you are backing up Rancher. And if you wipe up etcd, you're basically wiping up all Rancher data. And as you can see, Rancher server talks to multiple clusters. So here we have a GK cluster, GK nodes, and on the left we have RKE. So RKE, Rancher Kubernetes Engine, is our Rancher product for spinning up Kubernetes clusters very easily. It's very easy. It requires a very minimal cluster YAML file. And if you're looking to set up a cluster by yourself, by itself, it can be very handy. Okay, so today we're going to go through a couple of basic Kubernetes resources. There are a lot of resources, but these are just going to be the basic building block of Kubernetes knowledge. So let's start with pods. So pod is the smallest unit that can be deployed in Kubernetes. It can consist of one or more containers that are always run together. So containers inside of a pod are always spun up together. Each pod is given a unique IP address, and similar to services running on your laptop via localhost, they can talk to each other. Just like that, containers in a pod can talk to each other via localhost. However, this can get a bit confusing because you can have multiple containers in a pod. So most times you will have services that have pods which contain a single container, but sometimes there will be other services which inject of what is called a sidecar. So first you will have only a single container, and then you inject a second container which would be referred to as a sidecar. So for the majority of this training, we are just going to assume that pod is just one container, or pod is just a container, and that will make things a lot simpler. So here we see a general overview of a pod. There's Nginx on the right, there's Nginx on the left, there's Redis on the right, and they can talk to each other over localhost port 6379. So it's exactly similar to running on your laptop, these two services talking to each other, nice and easy inside a single pod. Designing distributed systems. This is a very good book. It talks about different design patterns that you can see in a system like Kubernetes. So if you are interested and if you want a base knowledge and vocabulary of all these terminologies, we do recommend that you refer to this book. Moving ahead to replica set and replica controllers. So replica set is basically the next generation of replication controller. What they're going to do is they're going to define the desired state of a group of pods, and then that is going to drive the controller to achieve that desired state. So what that means is that let's say you're requesting 10 pods with some definition, and you currently only have 2 pods. Then the replication is going to try and make that happen for you. So depending on the space constraints and other constraints, it's going to do its best to give those 10 pods if you're requesting 10 pods. So here's a quick example of how the replica set is going to work. For example, we're running here a replica set and we have requested 12 of these pods. So these 3 boxes, they represent our servers. So currently we have 12 pods running on 3 nodes. Now, let's say something happens and one of our node goes down. So now I only have 8 pods. What the replica is going to do is it's going to check and see if I have room to spin up these 4 missing pods. So let's say we are lucky enough to have large nodes and we have enough room. So the controller is going to reconcile and try to bring the system to a desired state of 12 pods. Moving on to deployments. So deployments, they are kind of above replica sets. They will control a replica set for you and they'll create and update replica sets. So if you create a deployment, it's going to create a replica set, which will go in turn and then create your pods. Now, one of the advantages of a deployment over a replica set is that it does give you rolling updates and rollbacks. So it kind of makes scaling easier. So as an example, we'll take a look at how upgrade work. Now there are 2 types of upgrades. All at once upgrade, which will obviously just kill all of your services at once and start new ones as version 2 or v2. So in this example, we are going to consider these 4 pods as v1s. Let's say we want to do a rolling upgrade of 2 at a time. So it will spin up v2. So now we have 2 pods of v2 running and 4 of v1 running. Now the system is up, we can do some testing, and once we determine that v2 is good enough, we are gonna do a 50% traffic split at this point. So half of the traffic is getting v2, half is getting v1. Now everything seems good and they decide to run v2 completely. So now we are running v2. All of our traffic is running v2 and everything seems good. But let's say there is some major bug in v2 and we need to revert it back. So we can instantly revert it back to v1, kill all of our v2s and go back to v1s. Basically, we can do rollback with deployments if something goes bad. Talking about services. So service is basically a DNS entry that can be used to refer a group of pods. Um, it provides a consistent endpoint for the group of pods. What does this mean is that the pods beneath the service, their IPs can change, but the service IP is always going to point to your current pods, whichever are running behind the service. Um, a point to note is that it is a DNS entry, but it doesn't guarantee that it is external. Sometimes services are just seen as external access to pods, but that is not necessarily true. It really depends on the type of services, like what type of service it is. And let's talk a bit about the different types of services. So node port service is going to give you a port on the particular node. Cluster IP is going to expose an IP in the cluster. And so cluster IP is not external, but node port can be external depending upon how the node is set up. Other option is going through a load balancer. So it's going to be a layer 4 TCP. It works with different cloud providers to create a public IP address for your app. So here's a basic example. We have a deployment running and we have set up a service which is going to have its own IP address. So when the internet hits the service IP, it will load balance across all these pods. The arrows do seem like they're targeting specifically one pod and all of these servers, but what we basically mean to say is there needs to be more arrows and they're going to be load balancing between all of these pods. Config maps. Config maps, they allow storing just any arbitrary key value pairs. So we can store different configuration for pods. Let's say there are different environments like dev, testing, production. They all will have their own configuration values. So instead of having and storing something in an object called secret where you store sensitive information, config maps, you can just store any arbitrary configuration values and files. So when your pods come up, they can pull this information from these config maps, either from the local storage or environment variables. So if you take a look at this, Here we have three different configurations, like for QA, dev, and for running in production. So inside these pods, you can see that it is the same Nginx and Redis image. But because of the data that we are passing in through config maps, it could change the behavior. So for example, your dev Nginx might not support HTTPS, but your prod might. So basically just different options and different ways to pass in the config without having to actually change the pod itself. Next, talking about Ingress. So Ingress is kind of the most common use case for directing internet traffic into the cluster if you're not using anything like BitIP. Um, so it's used to route your traffic into your internal cluster services, and it does that based on the host and the paths that you provide. We do use Nginx controller as our default Nginx controller, but there are a lot of other options. You can use HA proxy, AWS, and so on. So I think this is an example of how Ingress works. Um, Depending on which host, so here you have cluster.com and the path is my Nginx app, and here there is another host. So based on what host and path do you reach, the Nginx controller is going to route to the particular service IP, and that service IP is going to load balance across all of these pods. Matthew, I think we should stop for questions. So are there any questions at this point?
Actually, there's no questions, Kanara, so you keep going. I think most will come. Um, oh, somebody literally just put a question. This is Daniel, and he says, is the ingress only reachable from inside the cluster?
So Nginx controller is running inside the cluster in this example, and I don't really get what does he mean by reaching the ingress. So when you're running from outside, when you hit this path, you're going to reach the ingress from outside, and that's going to route you to a particular service which is running inside the cluster, and then it's going to load balance across all of these pods.
Okay, awesome. Yeah, and Daniel, if you didn't get your question asked or you meant something different, just ask it again. Okay, yeah, keep going, Kanara. You're doing great.
So now we'll be talking about Rancher 2.0 101. So like these are the different pieces that we'll be talking about today. How to set up a Rancher server, deploying clusters. We'll talk a bit about auth and security, storage, projects, namespaces, catalogs, and then we'll finish off with a bit of CLI pieces. So demo time. Let me just go ahead and move to my setup. So let me first go and show you the docs. So the fastest way to reach the docs is rancher.com, learn, and then under that rancher docs, and read the docs, installation, single node installation. So this is the single node installation is kind of the easiest and the fastest way to get up and running with Rancher. It's going to spin up a Docker container that's going to run Rancher service, and it will allow you to provision your clusters. So again, feel free to follow along if you have a Linux host somewhere. So we do support multiple different operating systems, and here is just a quick overview of how much hardware you would need depending on the size of your cluster. And we do have some specific supported versions of Docker. So if you're not running any of these supported versions, we wouldn't be able to guarantee that everything will be working for you. Now, in most of our dev setups, we do use unsupported Docker versions, and we don't see a lot of issues, but it's highly recommended to go with the supported versions. So looking at the ports, we're asking these ports to be open so that Rancher can talk to these different services. For example, we need port 22 so we can SSH into other boxes and talk to Kubernetes. So when you're installing Rancher, you have multiple options for SSL. The easiest option and the way that we're going to do today is to just use a default self-signed cert. So the first option with this, in this way, it's going to create a default self-signed cert by itself, so you don't have to do anything. The option B is that you can bring your own certificate. You can also use a certificate that is signed by a recognized CA, or you can just use Let's Encrypt. So Let's Encrypt option is pretty cool because it's very easy and it's a very quick way of getting a valid CA. Obviously, you will still have to run the domain name that you want to use, but it allows you to do it very quickly. So creating a setup is actually pretty fast. All that we're going to do is just have a Linux host with a supported version of Docker and run this command. This is going to give you Rancher server up. Now, all of the stuff is on Docker Hub. So if you want to just run the server or any of the images that they're using, it's just pulled out of Docker Hub. We do use WebSockets to communicate to our clusters. So, and we want access to 443 so we can talk to the management plane. Now, there's a few exceptions to this. So going back to our ports diagram, you can see that when you're hosting a cloud provider like GKE, EKS, or AKS, we do require 6443 inbound. So we can actually talk to the management plane. So for example, in GKE, you don't own the management of the cluster. So you basically just have nodes running there. So we need access to management side of it in order to provision and move things around for you. Now, if you're doing IS or custom clusters, then we need access to port 22 so we can SSH into the host and install Docker and install Kubernetes. So for example, if you have a bare metal and you want us to spin Kubernetes for you, then you would need to have port 22 open for that. So right now I already have a setup up and running just so you don't have to watch it build. But basically, if you're following along and if you just use this command, it's going to bring you to this front screen, which is going to look something like this. And if you go to your server where you just started this, and if you do a Docker PS, you'll be able to see that it's just a single command which is running Rancher. So when you log into the Rancher server for the first time using a self-signed cert, because we are using self-signed cert, it's going to ask to validate it. So you'll log in, you'll accept it as valid and add an exception for it. Also, when you first log in, it's going to ask you to confirm your server URL. So this is based off the URL you used to go to log in for the first time. I'll show that in just a minute under settings, but if you are following along, this right here would be your server URL. Let's go, and one more thing about the server URL. So if you have a setup with clusters that are running on the internet, you can't use localhost as your server URL because we won't be able to do any health checks against localhost on clusters that are not local. So you will have to then use something to give us an external IP and expose your URL publicly. So as you can see here, I've already set up GitHub as my auth provider. You can also use local auth, which is what it would ask you to do when you log in for the first time. I'm just going to use GitHub so I can show a couple of features that come along with that. So when you log in, this is the main page. And a quick look at first the settings, which is here on the main tab. And you can see the server URL that we were talking about. Once again, if you are using localhost, you are going to have a hard time setting up clusters that are not running locally. Now I'm going back to our main page. Today we'll be talking through three main different levels in the hierarchy, which is global, then comes the cluster level, and then project. So the first thing that we're going to talk about is auth. As I mentioned before, I'm using GitHub as my auth provider. It's kind of really easy to set up your app with GitHub. You just grab your keys, authorize on GitHub, and you're good to go. Another thing about this is that I can add users to my Rancher cluster. Let's say I'm just trying to type in something, and it is because I'm using GitHub, it is going to pull in from any user that is in GitHub. So if I just start typing in here, it's going to give me names that match with this username. We will talk about other pieces of auth at a later point, but as you can see here, we support different auth providers and we are open to adding new ones, which is always based on people's demands and their need for them. So when we initially started, we kind of had like only one auth provider, and then we kept on adding, and then Ping Federator and a couple of these were added just very recently. So do we have any questions at this point?
Yes, actually, it's perfect timing because Jared had asked, does Rancher support SAML or other enterprise centralized log technologies other than GitHub?
Yeah, as you can see here, we do support OpenLDAP, we support Ping, we support free IPA, we support AD, so yep. And here goes your SAML Ping federator.
Awesome. And then thank you. And Jana Kiraman asks, this is going back actually to the talk about Ingress. He asks, is Ingress something like a web server?
Hmm. Um, I don't know how exactly to answer that, but you can consider that as something which it's like a specialized routing based algorithm that's going to route your traffic to different services based on what path and host you select. I'll have to go and look at exactly how I can explain that in terms of a web server. Sorry.
Yeah, no, that's fine. That's good answer. Um, cool. That is the only questions so far. Keep going.
So going back to our global view here, it's going to show us a list of different clusters that we have. So currently, I just have one cluster which is running DO, and what it shows up here is that there is a provisioning host. It will give you different status information here, and once it provisions the droplets, SSHs in, installs Docker and Kubernetes, it completes all the checks, and then it gets pulled into the system and it shows state as active. And so let's talk a bit about adding a cluster first. So there are a lot of different options here, but if you look at these top three, they are hosted Kubernetes providers. So for these setups, as I was saying before, all you need to do is provision your access information. We won't provision these. We won't provision hosts for these clusters. So in these situations, all you have to do is just give us our access information and we'll provision the cluster for you. The second one is through IaaS services, so like EC2, Azure, or DigitalOcean, which I just showed you before. Here we will provision the host for you. So we'll need access to port 22. You can go ahead and enter your details here and it will bring up a cluster as we saw on the previous cluster page. Talking a bit about the custom cluster. So this is a situation where you already have a host. It doesn't need to be provisioned, but you want to start up a cluster in that particular host. So what you can do is just add some name, member roles. So again, because I'm using GitHub, I can just go in and type in different users, and it also allows groups. So here Rancher Labs is a group. So when I add this here as a member and I give it member role, uh, it's it's just going to say that anybody who is a member of Rancher Labs would have access to this cluster as a member. Looking at the options for cluster options, we do provide different options for Kubernetes version that you can run in. We have different options for network provider. So we have Flannel, Calico, and Canal. The difference between them is how they're going to be set up. The default is Canal, which is like kind of the best of both worlds because it's like the best of Flannel and Calico. It gives you the support of network policy. And again, we give you more freedom with this starting 207. So starting 207, we're also going to give you the option of selecting whether you want those network policies created or not with Canal. So you can see that with Canal, we have the option to enable or disable the network isolation. But with Calico and Flannel, it's just going to be disabled by default. Similarly, you have the option to turn on or off your Nginx ingress, metric server monitoring, pod security policy. We'll talk a bit about pod security policy at a later point. As I said before, you can always go through the route of saying that allow unsupported versions. That's fine. But if you say that the nodes should be running a supported version of Docker, if you try to bring a node that is running unsupported version, it's going to get error out and not allow creating of the cluster. The last of these options is cloud provider. So if you select one of these, it just gives us it just helps us to select the host for you. So for example, for Azure, you can select a bunch of different options that are specific to Azure. And here's a link that you can go to know more and look at these different cloud providers. Another thing that you can do is you can just grab this file and you can just edit it yourself. So if you already know the different options and different things you want, you just say edit as YAML and you edit it yourself. So it's pretty easy if you know what you're doing. The other options we can also read from a file. So for example, if you have a cluster running somewhere else, you can just export its the config information as YAML, read from that file and pull it in. Um, and now I'm going to import a cluster, and this is what I'm going to do today so that you can see how importing a cluster works. I'm going to give it a name, and I'm going to add Rancher Labs as member as we discussed before. And you can see that when we are trying to import a cluster, we don't see any of the cluster options that we were seeing before. You just see name and member. And that's because when you are importing a cluster, you are saying that you already have a cluster. It's running somewhere else. You just want to pull it in and allow Rancher to look at it and perform some operations on it. So I'm just going to go ahead and create this. And it gives you three commands to import a cluster. All three are going to do kind of the same thing. But since we are using self-signed cert, I'm going to use the third command. Otherwise, we'll get certificate signed by unknown authority errors. So I'm just going to done this first. And let's see now on the main page, we have an imported cluster which shows up on the list. It says pending. What this means is that we have told Rancher that we're going to be importing a cluster, but we haven't actually done anything in the cluster. So it doesn't really know anything about it. It's waiting for the configuration. And so let me go ahead and use that command to import this cluster into Rancher. So here is my cluster, and you can see the namespace is currently in the cluster. This cluster was spun up using RKE. As I was saying before, all I had to do was to give it a simple YAML file. And here is a sample YAML file, which you will also find on RKE docs. So all you have to do is give it a node address, node IP address, and your SSH keys, and the roles that you want to assign to the particular node, and it's going to spin up the cluster for you. So this is my cluster at this point, and I'm going to use the command to import it. So here you can see that a few things happen. A cattle namespace got created. So for any cluster that is going to be a part of Rancher, it's going to have a namespace called cattle system. It also set up a service account, a role binding, secrets, deployment, and basically all the different resources that Rancher needs to manage this cluster. So the main thing that we can look at is that namespace cattle system got created. And what all is there in this particular namespace? So we can see that a couple of agents, a cluster agent and node agent, are the ones that got created. These are the agents that talk to Rancher. Earlier, I was mentioning that we open WebSockets. So these are the agents that open them. So the communication can actually take place to Rancher server. We use WebSockets because it makes them easier. We don't have to open and close them. We have a WebSocket. We can talk back and forth, and it makes things simpler. So now if we go back to UI, we can see that the cluster has been imported. It pulls up the other information which was earlier empty, like the number of nodes, the usage information, and its state is active. So just a general information about the cluster. Do we have any questions at this point?
Yeah, we do. Let's see. So going back to a question about authentication,
Mhm.
Christopher says, can I specify more than one domain controller with Active Directory authentication?
Okay. Unfortunately, that's like a bit very specific about a particular auth provider that I don't know about. So you can like it would be best to just jump on to Rancher user Slack, and I'm pretty sure there are engineers who have already worked on this who would be on the group and they'll be able to answer it pretty quickly than me trying to find out.
Yep, perfect. Okay, great. Yeah, rancher.slack.io, Christopher. Okay, and Raphael asks, so this is going back to Ingress again. Is the Ingress running as a container on a server?
So on Rancher server, it's actually Ingress controller, Nginx Ingress controller, which you will be able to see in the Ingress Nginx namespace. Here is where the controller is running.
Great. Cool, thank you. Chris asks, and maybe might be outside of the scope of this intro training, but he asks, how does Rancher work with F5 load balancing on-prem?
Yeah, that's like kind of you will actually need to put this up on user Slack or Matthew. Like I don't really know if we really support all kind of different load balancers. So that's like a question for support people.
Yeah, I thought. Yeah, Chris, ask if you could ask on the user Slack. I'm pretty sure we do support F5 load balancing, but again, the engineers on the Slack channel will be able to help the best. Okay, Daniel asks, what exactly are the roles worker, etcd, and control plane?
So when you set up, when you're trying to set up a cluster, and let's say when you add a particular node, it gives you three options. So etcd is basically the database. Control plane is where the controller, where basically all the control things happen, and then there's a worker node. So when we start up nodes through RKE or through any of the IaaS or custom clusters, the etcd and control plane nodes are basically unschedulable. You can't schedule anything on them, and worker node is going to have all your deployments and all your workloads that you are deploying on.
Okay, cool. Thank you. And then Sue asks, will Ingress have high availability?
Hmm. That depends on how we do HA. Currently, we just have a single Rancher server set up, and we just have this one ingress which is running. So at this point, I'm not really sure how we can support HA for specifically Ingress. So if we have, so if we are running a Kubernetes cluster and then we are running Rancher inside of it, then it is on Kubernetes to have some failover mechanism. But on a single node cluster, if a server goes down, then there's no support for Nginx controller as well.
And is that true when you deploy Rancher in HA mode too?
Um, so HA mode currently yeah, I'm not sure because I know that initially we had plans of supporting and we currently are working on having multiple rancher setups, but currently it's just a single rancher server which is running inside of a Kubernetes setup. So it basically depends on that Kubernetes setup, how it was set up and how it was planned to do the failover stuff.
Cool. Okay, thank you. Um, good questions. And there's one more, and then we can continue the demo. And this is from Chris. Asks, in regard to issuing certificates from an internal trusted CA, can an issuing CA certificate be installed on Rancher so Rancher can can distribute trusted certificates?
Um, I'm sorry, I don't know. So I know that for a single node setup, we just generate this cert, and I don't know when it expires or how we generate this. So I don't think you can just distribute it, but you'll have to you'll have to see it in the docs.
Cool. Okay. Awesome. Yeah, keep going. Lots of good questions and keep them coming, everybody.
We were looking at the global page here when we stopped, and as I said, there are three levels to it, like global, cluster, and project. And now we're going to go inside and look at the cluster level. So when you go, I'm going into the DO cluster, and this page is going to give you a nice little summary about the cluster. We have health checks, we have usage information, what version you're currently running, what provider it is. So we do use Docker machine to provision hosts. So it gives you information about how we are provisioning the host. So currently it just says that we are using Docker machine and DigitalOcean on DigitalOcean host to provision this node. Just some basic information. One really nice thing about UI is that you can launch kubectl right here. So if you're not familiar with Kubernetes, kubectl is the command line to interact with your cluster. So when you start running multiple clusters, then you would need to deal with context and switching context. So context is basically what cluster and namespace you're looking at. So the nice thing about this is that if you launch kubectl from here, you are automatically in the correct cluster. The way this works is we actually go and talk to the cluster, we pull the kubeconfig, and we open a shell directly in the cluster for you. So this is exactly similar to running this kubectl inside the cluster. You don't have to worry about context, you don't have to worry about kubeconfig, and it just works. Other thing is that if you don't prefer to run it here and you would prefer to run it locally, you can just grab this kubeconfig file. So you can just use this kubeconfig file to get to your cluster resources, in this case, your DigitalOcean cluster resources. Taking a look at the nodes, so something to note here is that depending on how you created the cluster, it changes what you can do with the nodes. So because this cluster was created through Rancher, I can scale these nodes, and it's just going to go out to DO, provision the host like it did the first time. But to show you the difference, if I go to an imported cluster, and look at my nodes, there's no such option here because the cluster was imported and Rancher doesn't have any control over it. So it can't go and create additional nodes. So to add a node, you would have to go and provision them however you provisioned them initially. If you look at the cluster level again, um, if you have scaled up your host, you will see that information getting reflected here that your nodes are not active and which particular nodes are not active. Going to storage. So trying to do storage with Kubernetes can be a bit complex. They give you a lot of options, a lot of knobs to do, and here we're just trying to make it a bit simpler. So to add a volume, you just give it a name. you select a volume plugin. This just tells you where the storage is coming from. So if you're running Google, you probably don't want to use Amazon because there are issues with cross-cloud storage. But overall, just like use whatever you are used to, and then based on what you are selecting, you will see that its particular configuration option changes. So for if you select Amazon, it's going to ask you about partition. It's going to give you some access modes. These are just the typical options that come with these plugins. We are just trying to put it in a nice and easier way. The next is a storage class. And here you will see that there are a couple of provisioners again, and similar to persistent volume, sorry, you will be able to select any provisioner that you want, and its corresponding options will change. Moving on to projects and namespaces. So project is a Rancher construct. So it's not a Kubernetes resource. So if you go to the cluster, launch a kubectl like I showed you before, and if you try to get the object project, there is no project. It doesn't have a resource type project. And we just use a CRD to keep a track of this. CRD is a custom resource definition. So you can create a CRD and Kubernetes keeps track of it. So basically, in every Kubernetes cluster, there is a namespace, and we are just trying to group these namespaces into a project for easier control. So for example, if you have a dev team, and if you have only 3 devs, you can give them their own separate namespaces. But if they have some common certs and secrets that you want to assign, and you don't want to do that for each namespace, you can just combine these namespaces into a project. So it just gives you a nice access control. The things that you want to keep together, you can keep them together. For the ones that you want a finer control, you can keep them separate as their own namespace. It is one-to-many relationship. So a namespace can belong to only one project, and a project can have multiple namespaces. You can also move namespaces between the projects, and I'll show that just in a minute when we create a namespace or a project. So let's go ahead and first create a project. And you will see that right now it has no namespaces. A project doesn't really do much without a namespace. So let's just go and add a namespace to the demo project. And you can see that you can move this namespace around. So you can move it to none, then it just becomes a simple namespace, but it doesn't belong to any project, or you can move it to default. So when you first start your cluster, it always has 2 projects. Default containing the default namespace. Kubernetes always has this default namespace. There's nothing particular about it. The next is system. This has all the namespaces that are related to our system processes. So you probably don't want to put anything in here unless you know that you need to. But even if you do, kube public and kube system, you probably don't want to touch. Nginx Ingress is where the Nginx Ingress controller lives, as we saw before. Cattle system contains cluster and node agents and whatever else we need for Rancher that we saw in the imported cluster page. So another note about this is that you can delete any of these namespaces. So let's say you go and delete cattle system, which is under a system project. That basically just takes Rancher out of your cluster. So let's say you imported a cluster and then you decided that Rancher is not for you, or you want to take some another route. You can delete the cattle system namespace and we would have no longer communication with the cluster. Also to note that we do add some labels and annotations to resources, but it doesn't really have any implications. It's just going to live on your cluster as some metadata on top of these objects. And Let's talk about cluster members next. So we already did add a cluster member Rancher Labs in here, but you can always add more members to your cluster from this page. You can again search for any user that you want. It's going to pull in from GitHub. You can give it owner or membership role, or you can also define your own custom roles based on what do you want. We also have tools like alerts, notifiers, logging, and pipeline. We won't really be able to go into all of them in detail, but basically alerts are something as to they're going to alert you when there's some condition. So we have a few default ones that are already being created. So when a node memory goes over 70%, you want an alert. You can always go and add alert based on whatever service you want. What event do you want, if it's a pod or a deployment event? And you can choose to select what do you want to do when this alert happens. You would need a notifier, so you can go to your notifiers and create one here, and this is how the alert is going to notify you. So this was how we were. This is where we were talking about the cluster view. And let's go back to our global view and look at catalogs. So catalog, there are two layers to catalogs. Catalog itself is just pulling in information, and library is a list of these curated catalogs. They're basically Helm catalogs that we have gone through and we have made them a lot easier to use by just giving it some same defaults, and you should be able to easily use them. They would just work out of box. If you want, you can use Helm stable. Helm stable is just like a Docker hub for Kubernetes. You can go ahead and enable it here, or and it's going to give you a list of more options in there. So catalog is your access to apps, which is basically just YAML files that tell Kubernetes on as to how to launch your application. So like what services do I need, what pods need to be running, what's connected to what. You also have the option of adding a custom catalog. So if you have your own curated list of catalogs that you want people to use, you can go and add a custom catalog. Um, just give it a name and a URL. Currently, we only support Helm catalogs, so it just needs to be a Helm catalog and we'll be able to use it. I'm going to go ahead and show adding a catalog. So let's go to our default project and then catalog apps and click on launch. So again, we don't change anything in these catalogs. We just give it some, most of these catalogs, they don't really just work out of the box. You need to give it some configuration. So all we do is just give in some basic defaults and make them work with Rancher if they belong to the library catalog. So this is, here you'll be able to see all the different categories that we have. And currently we just have library catalogs. So you will just see a few selected catalogs. So I'm going to go and launch one of these. You will see that when you launch one of these, you will see that it comes with its own proper description of how to set up things. Here it asks you for configuration options. So by default, we launch the catalog into the namespace that is exactly named as the catalog. Sorry, you can always go ahead and customize it. Um, so here it's asking you for a couple of configuration options. Similar to the cluster, you can always edit the YAML in here. You can read from a file. And this file, where you're putting in answers, we call it the answers YAML. And another thing that you can do is that look at how the template files get generated from these answers YAML. So basically this file is contains all the inputs that you give for your different configurations. And we take these values and from in here and put into the corresponding files that are required for running a particular catalog. So you can see that sometimes it takes a lot of files to make it work. And right now I don't need to do anything. I'm just going to launch it because it's going to work. I hope it works out of the box. So when it is deploying, we can go into workload and, oh, it's already up, but basically when it is deploying, you can go to your workload screen. And this is the first time we are looking at the workload screen, so let's explore it a bit. You'll be able to see how many pods are running. You can go into the workload and you can see a couple of just different information about this workload. What ports is it using, what health check is it using, volumes, and the labels and annotations on the deployment, and so on. And you can also go and edit it here. So let's say that if you decide the health check is not working, you can just go ahead and edit the workload here. So one of the other things that Rancher does is that if your application has a public exposure, we do try and expose it and give you a way to click on it. So we we also, I think we built an XIP IO depending on what you select. So when we launched a catalog app, the default was selected as XIP IO. So if you go onto this link, you will see that it generated a URL and this is currently exposed to the internet. Catalog apps also support upgrade and rollback. So currently, I just launched it from my library and it had only one version, so I won't be able to upgrade. But if you launch it for some other catalog or if you have Helm enabled, you will be able to see a lot of different versions that you can upgrade and roll back to. So you can also delete the catalog. So if you delete the catalog, you'll be able to see that the workloads page is empty again. If you go to namespaces, you will see that the namespace that we created for Grafana is still there. Basically, we don't clean up the namespace because there could be other things that are potentially running in this namespace and we don't want to tamper with it. But you can always go ahead and delete this namespace. Talking about project resources, we talked about alerts. There's certificates, there's logging, there's registries, there's secrets. Secrets and certificates, they are at two levels. Project level, which is available to all the namespaces and the project, or it is available in a single namespace. So just as I was saying before, if you want something that needs to be available to all the namespaces, just create a project level secret. So do we have any questions at this point?
Let's see. There aren't any additional questions actually, Kanara. So yeah, you can keep going.
So before I go to the CLI bit, I think I do want to talk about one more thing, which is at the global level, under security, pod security policies. So pod security policy is a Kubernetes construct. It's basically an object that defines a set of conditions that a pod must run in order to be accepted into the system. So you can set up different policies that is going to say how your pods run in your cluster. So escalation privileges, what they can do, who they can communicate with, a lot of different knobs. And we can see at we can have a look at the two pod security policies that have been already created, restricted and unrestricted. So restricted is basically just all no. It's the default pod security template and it doesn't allow any privilege escalation. But let's say you're running in test, you're just running for test purposes, you want to see how it works. Sure, you can allow privilege escalation for your pods, you can allow host networking, and so on. So this is just another bit on top of RBAC to keep your cluster safe. If you're planning to run a setup in production, you should definitely consider looking at pod security policies. So moving on to CLI, you can download CLI from right here at the down of this page. I've already downloaded the Mac OS, but it basically just does nothing. It's just a zip file. You have to unzip it and you're all set. So the first thing that you need to do is to configure this to have access to your server. It needs some way to talk to your server. So the way to do this is to go in here and create an API key. So I'm going to go and add a key. You can tell it when to expire. So let's just say it's going to expire a day from now, and I generate a demo key. The way to log in is just take in your token, and I'm going to pass this in here, and I'm going to give it the server URL. And when you do this, it's going to just ask if everything is okay, and now it asks you to select which project do you want to set as your current context. So similar to Kubernetes, we also have an idea of context. So in this way, here the context means the cluster and the project that you are currently running in. So right now I'm just going to let's say I'm going to select the demo, I'm going to select the default, or I don't have anything in default, so let's select the system project for import cluster. So as soon as you do select this project, it's going to save this config, and now you can do rancher nodes, rancher projects, rancher. Basically, you can get all the information that you do similar to a CLI. But something about a Rancher CLI is that we don't get in the way of Kubernetes. So even though you have the CLI, it will still allow you to do Kubernetes things. So you can still go ahead and do Rancher kubectl get namespaces, and it's still going to work. But basically, Rancher CLI is used to give us access to a Rancher constructs like projects because they don't exist through kubectl. You can we also allow pass-through to Kubernetes. So when you do Rancher kubectl, um, it's just basically the full kubectl. So you don't have to go into a particular cluster and launch kubectl in the UI, or you don't have to get the kube config, and you don't have to keep on changing projects. You can just do everything in here with a single command. If you want to switch between projects, you can use rancher context switch. It's going to ask you which project do you want to switch to. And now if I select the default project for your cluster, it's again going to go and grab the kube config for that particular cluster. It's going to save the config, and it's going to give me a project level view in here. So basically, we're not hiding anything. It's just something additional on top of kubectl to give you access to your resources. Matthew, I think that's all I have. Are there any questions, or do you want me to go to any topics again?
Yeah, there's another question. This is from Craig, who asks, can you add additional volume plugins in Rancher? For example, the Nutanix volume plugin for Kubernetes does not seem to show up in the list.
So we do try to keep up with all the plugins that are generally available under Kubernetes. And if you don't see any, I would assume that you should like just let us know. And I think maybe we skipped on it, or I'm not really sure if there was any issue with it. But yes, all the volumes that you see under Kubernetes should be available here.
Okay, great. And did you show the app catalog?
Yeah, I did. Do you want me to show that again?
Yeah, can you just show the additional um, some of the additional integrations there?
Yeah, so if you go and try to launch catalog, here are the list of library catalogs that we support. If you want to see all the additional ones, you can go and enable Helm, and then when you go to launch catalogs, you'll be able to see a lot more. which are specific to him.
Awesome. Thank you. I just want to make sure that got into the recording. And Daniel now asks, says the communication says, is the communication between Rancher and nodes encrypted out of the box?
I would assume it should be, but I cannot say that on the top of my head. Sorry.
Okay. Do you know a place in the docs where Daniel might look for that, or is it best to just ask on the user Slack?
I think it is best to ask in the user Slack because we just put in a very introductory information in the docs. Like it wouldn't really talk a lot about how the actual communication works. So you want to like dive into the internals. It's better to ask in the Slack and you'll get a more descriptive answer.
Okay, cool. So we do have more time. If you've gone, is there anything else you want to show? Otherwise, there aren't any questions, so we can just end early for this one, which is okay.
Can't think of anything right now. So yeah.
Okay, cool. Then I am going to go ahead, since there aren't any other questions, I'm going to go ahead and take the presentation back to just show the last couple slides. Let me change the presenter. All right. Can you see my screen?
Yep.
Okay, great. So as was mentioned several times on this call, please continue the conversation and other questions that come up on the Slack channel, so slack.rancher.io and hashtag Kubernetes channel to get just more help. And you guys will be getting an email follow-up with this recording as well as the slides and the Q&A. And we have more info on rancher.com/Kubernetes, or you can reach us on Twitter at hashtag RancherK8s. Otherwise, that's all we have. Thanks so much, everybody, for being here. And Kanara, thank you again for going through the demo and having it all set up and answering our questions to the best of your ability. Really appreciate it. All right, everybody, have a great rest of your week.